Okay, guys, today we're going to start our intro into calculus. Let's first talk about what does calculus mean. I know it can be an intimidating word. If someone were to come up to you and ask you what is calculus, you could easily tell them the study of change. So we'll be beginning our study of calculus by looking at the simple idea of slopes. Be careful not to lose your footing whenever we discuss a rate, that is, how one quantity changes with respect to another quantity. We are talking about a slope, which is nothing more than a rate of change. For instance, when you talk about miles per hour, feet per second, you are talking about a slope, and consequently, we're talking about calculus. Okay, so mathematically, the simplest object about which to discuss slopes are straight lines. We know how to find, or we should know how to find, the slope of a straight line. This formula here should be familiar to you. And let me just remind you at any point during this, if I'm going too fast or you need to rehear something, don't hesitate to rewind. Remember, the triangle is the Greek letter delta, and it stands for the change in. And sometimes you will see slope written as delta y over delta x, which is the change in y over the change in x. Now, this is Algebra 1, but I will go over it with you. So, to find the slope given 2 points, we want to take the change in y, so take your y coordinates and subtract them, and then take your x coordinates and subtract them. And so we get a negative 3 over negative 7, which is a positive 3/7. So that would be the slope, or the change in the line from negative 2,3 to 5,6. Another way that you will sometimes see this formula, and the way we're going to first start this off is talking about a secant line, and this format of the slope formula. That's all we're going to be doing today is slope formula, guys. So don't sweat it when it looks a little bit more complex, but that's all we're doing is slope. And this formula right here will be used more often today, and it'll be one of the formulas that we need for the secant line, which again, it's just slope. So the slope of a line, most commonly used with y equals mx plus b, where the slope is constant for any and all points on the line. So that is considered an average rate of change, but since all the points are on the same line, it is also the instantaneous rate of change. It's always changing by that slope. Finding slopes of lines is easy, but what if you want to find the slope of a curve? And technically, so really when we think about that, it's not a slope because we have an idea about what a slope looks like. It looks like a diagonal line. And so we're not really going to use that terminology anymore, slope, as much as we are going to talk about the average rate of change from 2 points. And so slopes of lines are easy to calculate using the difference quotient. Okay, it's these two formulas right here. It's the difference. You're finding the difference of 2 points, two numbers, and then you're doing a division problem. So difference quotient. All right, so don't let that be confusing. But you need 2 points on a line, okay? And we would only have one with a secant line. So if we calculate the slope of a line between 2 points on a curve, we get the average rate of change, okay, on that curve for the interval, and the line is called a secant line. All right, so that brings us to example number 2, okay? So the first thing that we want to do when given an equation and being asked to find the slope of a secant line, and I do want to let you know there could be an infinite number of secant lines. We're just looking for, in this case, the slope of a secant line or the average rate of change from -1 to 2, okay, on that line. So the first thing we need to do, we've been given our x's, we need to find our y's, okay? And so some of you may feel more comfortable by doing your f of -1 and f of 2, so plugging your x's in and finding your y's. So we have -1 squared plus 1 which is going to be 1 plus 1 is 2. And so that gives us the point -1, 2. And then we would plug a 2 in. So 2 squared plus 1, 4 plus 1, 5. So that gives us the point of 2, 5. And then basically we're doing our little slope problem to find the slope of the line. I will point out also that you will also see it presented where they're doing the problem as f of -1 minus f of 2 over -1 minus 2. Okay, so it might be helpful to do this work first. I don't mind if you leave it like that. In fact, you know, with you guys having graphing calculators or the access to a calculator, if you have a graphing calculator, you could just look at the table. What is the y when x is -1, and what is the y when x is 2? Okay, so for finding that slope, given our 2 points, we take our y's and subtract them, and then we would take our x's and subtract them, and so that would give us -3 over -3, which is a +1. Now, I've graphed in Desmos what our original equation looks like. These were the 2 points that we were finding the slope of our secant lines, the 2 points we were given, and you can see the line that goes through those two. And if we look here at the steps to get from one point to the other, it's up 1 over 1, so in fact it is a slope of 1. Now, if they ask us to find the actual the full equation of the secant line, not just the slope, we would have to go back to y equals mx plus b and substitute in. So we'll just add that in right here. So we know the slope is 1, so 1x plus b. And I know a lot of you aren't going to write 1x, but just so you see that we plugged it in right here. We would plug one of our 2 given points in for x and y, so that b is the only variable that's unknown. And so we could plug in, say, 2, 5. So 5 is the y, 2 is the x, and so that gives us 5 equals 2 plus b, and I think it's clear to say that b is 3. So y equals x plus 3 would be the equation of the secant line, whereas here this is just the slope of the secant line. All right, so here's some extra examples for us to practice on. We got quite a few right here. And so let's look at example A. They give us this standard equation to use every time of x squared plus 1. So one quick way of writing this is f of -3 minus f of 5 over -3 minus 5. And again, like I said, told you guys earlier, if you need to pause the video right now so that you can get this copy down, you're more than welcome to do that so you can keep up with what's going on. And I'm actually going to zoom in on this problem so that we can, so it's easy to see if you're watching this on your cell phone. All right, so f of -3, this is pretty easy since there's only one x, so -3 squared is 9 plus 1 is 10, minus 5 squared is 25, plus 1 is 26. So on our top, we get -16. On the bottom, we have -3 minus 5, which is -8. And so that equals 2. So 2 is the slope of our secant line. And they are not asking us to find the equation of our secant line, only the slope. Okay, so for the next one, we would take f of -3 minus f of 2 over -3 minus 2. And so from our last problem over here, we know that f of -3 is a positive 10. 2 squared is 4 plus 1 is 5. And then on the bottom, we would get negative 5. So we would have positive 5 over negative 5, which is a negative 1. Okay? It's actually be a good idea to change colors between our examples. So let's look at this next example. Again, we have f of negative 3 minus f of 0. And just remember, guys, when I'm writing f of negative 3, I'm just writing, that's essentially representing what y is when x is negative 3. And f of 0 is what y is when x is 0. So negative 3 minus 0 on the bottom. We know what f of negative 3 is. F of 0 is not 0. 0 squared is 0 plus 1 is 1. And then we would have negative 3 minus 0 is a negative 3. So that gives us 9 over negative 3. So we get negative 3 as the slope of our secant line. Okay. Let's go green. All right, so I know this is getting a little repetitive with this f of negative 3, but that is okay. Now, be careful here because you're subtracting a negative 2, and it'd be very easy just to write minus 2, but it's, apologize for that. It is minus a negative 2, which it's going to make it a plus 2 in the bottom. But anyways, on top, again, surprise, surprise, we have f of negative 3, which is 10. And then on top, we have negative 2 squared. Negative 2 squared is 4 plus 1 is 5. So 10 minus 5. And on the bottom, this becomes negative 3 plus 2, which is a negative 1. So 5 over negative 1 is a negative 5. Okay? That is as far as we are going today, guys, on the secant line. Down here, I have a problem for you guys to practice on. This would actually be a really good time to hit the pause button. Below this are the answers. And then after you do this and you check your answers, you should be good to tackle your assignment. All right, so go ahead and pause. If you're now looking at this, I did write out the work just because there were two x's. So the f of negative 2 and f of negative 1, I just showed the substitution back into the original problem, just so that you guys would see where my numbers came from.